Part 3 of the Unit 3 review for applied stats is where we're talking about linear correlation and regression problems. First of all, we've got 3 graphs. We want to just look at the linear relationship that's represented by each of the scatter plots. And we have a choice between saying it's strong negative, strong positive, weak positive, or no relationship. If we look at graph A, notice that in general this is going up as it goes from left to right. The points are fairly close together in a pretty good straight line pattern. So this one we could say has a strong positive relationship. It's positive because in general it's going up as it goes from left to right. If we look at graph B, the points are just spread out. There's no real pattern to them. So here we would say there's no relationship. For graph C, again, in general, these points are going up as we go from left to right, but really they're pretty spread out. There isn't much of a linear pattern there. So we would say it's a weak positive relationship. It's still positive because it's going up from left to right, but the points are so spread out we would say it's a weak relationship. Now in the next problem, we want to match each of these 3 graphs with one of these R values. Remember, if we have something that's going up from left to right, that's going to have a positive R value. If it's going down from left to right, then it's going to have a negative R value. And if it's something like this one where there's no real pattern at all, then the R value is going to be very close to 0. So for graph A, since we said it has a strong positive relationship, that means the R value should be fairly close to positive 1. The one that fits that the best is the 0.908. For graph B, we would assume that this R value is going to be close to 0. The one in this list that's the closest to 0 is this one. For graph C, this is still a positive relationship. It's not going to be as close to 1 for the R value as graph A was. So the one that would be the most appropriate for that one would be the 0.719. Notice that we don't get a value of 1 or -1 unless we have an exactly straight line pattern. It has to actually have all the data points in a straight line to have an R value of exactly -1 or +1. Now we have a couple of problems where we're going to look at the scatter plot, we're going to find the correlation coefficient, and find the linear regression line, and then decide whether the regression line is an appropriate equation to use to make predictions or not. So first of all, we would want to copy and paste this data into StatCrunch, and then the first thing we're going to do is look at the scatter plot. Here's the data that I have copied and pasted into StatCrunch. To get the scatter plot as well as the correlation coefficient and the linear regression line, I'm going to use stat regression simple linear. So for my x variable, I'm going to take the age of the mother. For the y, I'm going to take the birth weight. I don't have to worry about marking anything down here. It should already be set up so that it will do the scatter plot and draw the linear regression line along with it. So I'm just going to click on compute. Here are my results. So up here, this is my linear regression equation. Notice it doesn't use y and x, it uses the names of the variables that I had. Here's my sample size, here's my R value, my correlation coefficient. And then when I'm looking at whether this would be a good model to use for prediction, I want to look at this table and I want to look at the slope row. And if I go over here, I've got my test statistic and my p-value. What I'm really interested in is my p-value. If the p-value is really small, like it is in this one, that means there's strong evidence of a linear correlation. So I could use my regression equation up here to make predictions. So if I look at my scatter plot, I can see that I've got a pattern that's going down as I go from left to right. So this would have a negative relationship. That's why my correlation coefficient turned out to be negative. So my scatter plot shows a strong negative linear relationship. My R value is negative 0.8681 that we saw in the StatCrunch results. Here's the equation of my linear regression line. Again, I got that from here. I just put in the Y for the birth weight and the X for the age of the mother. When it asks whether the linear regression equation is a good model for predicting birth weight based on the age of the mother, we're looking at the p-value in the slope row. Since this is very small, then probably no matter what our significance level was, the p-value would be smaller than the significance level, so there is sufficient evidence to conclude that there's a linear relationship. That means that if we want to predict the birth weight of a baby for a mother who is 21 years old, we would put 21 into our equation in place of x. So we're taking the equation that we had up here and plugging in our number for x and then just working that out, and we get 2130.3 grams. Here's another problem for linear regression. We're going to do the same thing. We would take this information and copy and paste it into StatCrunch. And in this one, the only two variables we're interested in are the interest rate and the months. So we don't even really need to copy the year into there. Here's where I copied and pasted this into StatCrunch. I want to do linear regression with this data. I'm picking interest rate for the X and months for the Y. And then I'm just going down to the bottom and clicking on compute. And first I'm going to look at the scatter plot. This shows not much of a relationship. I do have some points that seem to have kind of a pattern down here, but there are all these ones up here that are completely different. So I don't see much of a pattern there. If I go back to my results, I can pick out my R, my correlation coefficient is negative 0.3560. My linear regression line would be right here. The months was the Y and the interest rate was the X. So this would translate into Y equals 10.613 minus 0.6577x for my equation. Then when it asks whether the regression equation is a good model for predicting the number of months, the answer would be no, because if we look at the slope row in our results, the p-value right here is 0.1133. If we had a 0.05 or even a 0.10 significance level, the p-value would be greater than that. That would mean we'd get a negative conclusion, so we would conclude that there's not sufficient evidence to support the claim of a linear relationship. If there's not a linear relationship, then we can't use the linear regression equation that we had up here. In that case, we're just going to use the mean of the variable as our best predicted value. If we're trying to predict the number of months, then what we want to do is use the mean of the number of months that were in our third column here. So if I go back to StatCrunch and do summary stats columns, I just want the mean for the number of months. I'm picking months for my column, and I'm just going to let it do all these statistics, even though I just care about the mean. Here's the mean right here is 6.05. That's going to be my best predicted value since we concluded there was not a linear relationship. So that's all I have to do for that. In some of the problems, it'll even give you the mean. Remember that when we did the sample mean for a lot of things, we had X bar. If it's the sample mean for the Y values, then it's going to be Y bar, Y with a bar over it.